Thank you. Thanks. This is very much similar to what Gian explained, and I think you made my work easier somehow, and somehow difficult because I had to figure out what I'm going to say then. The idea is, Gian said their vision is adding a third eye to every person and allowing people to look in every corner of the world. What we are trying to do, we are trying to integrate that third eye to Internet. And we call it Internet of Things. Before I start going through this, just a question for me to understand the background of the audience better. Are you familiar with semantic technologies, semantic web? Have you ever used any of them? Yeah. And Internet of Things. Have you ever heard? Okay. All right. Thanks. Internet of Things, the idea is like we have you people, you make sensors. There are millions of them, and we estimate there will be billions of them by 2020. For example, Cisco claims there will be around 50 billion internet-connected devices, embedded devices. Many of them, they have sensors. The idea is now integrating those sensors and making them internet accessible. What we are doing is that our idea is now, why not elevate them to the document level? Let's make the sensor data be accessible the way we access data on Internet. We open a page, we open a web page, regardless of where it comes from. We have standard protocols doing this. Then in traditional sensor networks, we had, how does this thing work? Okay. Like we had sensors, they were communicating amongst each other, or we had a sync node, the data is transferred to the sync node, and then from there you transfer it or use it. Now in Internet of Things, the idea is these devices, these sensors, are attached to things or reporting information related to a physical object, for example, temperature of this room. And what I'm interested in is making this data available on Internet and representing this as a service, as Gian said. Then the whole framework is called Internet of Things, and there are lots of research in this area. And there is something going on in parallel on the web, which was started, I think, around 10 years ago. It's called Semantic Web. What Semantic Web is trying to do is to make web more machine interpretable, adding metadata, allowing machines to read and understand, not really understand, at least to be able to interpret what a web data means. What we are doing, we are trying to use the idea of semantic web and add metadata to our sensors, to the devices which report the information, and the objects which are attached to them, or they are attached to the objects. If you look at like a sensor network, this is just a very simplified view of a distributed sensor network. So you have this capillary network, sensor islands. We assume all of them are either directly can be connected to Internet if they are powerful enough, or via a gateway. You have a hub node. The nodes get associated to a gateway, and via a gateway they are connected to Internet. When you have a simple scenario like this, perhaps you know what sensors you have, you know what type of devices you have, and you can find and use them. The problem starts if you say, I have an Internet of Things. Then you have, basically, in theory, billions of these devices, different places. And I'd like to find a date, for example, a device which can report temperature of this room. How can I find this? And if I find this, how do I know what data it reports, in what unit of measurement? That's where you need some metadata to explain this information. Then the idea of semantic web is creating a situation awareness or providing information which are easily usable or interpretable for human and machine users. Ideally, this information needs to be interpreted via automated like agents, software agents, because you have huge amounts of data, large number of devices, and you want to extract knowledge or make decision or create actionable knowledge from this data. The basic step to do this is for us is to create them or represent the sensors as services. Then what semantics do for us? Semantics are sort of metadata. You add to your data. This metadata is machine readable, machine interpretable, and the root of semantic web is based on first order logic, and there are very mature logic standards for representing this metadata, and there are reasoner methods which can basically read and interpret this information. There are lots of off-the-shelf tools for this. Then there are some taxonomy of semantic webs. We have ontologies, which basically your schema of representing the different concepts, how they are related to each other. Then you have some metadata, which are instances you create from them, and you can represent all of them as knowledge base. I'll clarify some of them soon in a few slides. Then if we look at it in a layered model, if we try to put it in a layered model, we have things and objects in real world, like this room. We have sensor devices, which are reporting information related to them. For example, you have a temperature sensor here. You might have a number of these sensors, which create a sensor network or wireless sensor network. Now, you have the connectivity service running on your embedded device. It is powerful enough. You have enough energy to supply that. Or you connect the sensors, you associate them to a middleware, and that middleware provides the service connectivity to them. That's the point. Now you have the connection and access to the sensor network. Perhaps there are other issues related to this. We can get back to this and discuss it. And then there are other problems. If I have millions of them, how I'm going to discover them, how I'm going to use and monitor them. And then this device is also very dynamic. They can appear, disappear. You need to have some knowledge, some information about your underlying environment to be able to decide, compensate, compose, or do different processes. What semantics do for us? In the things level, I can explain, for example, this is a room. This room is located in Taipei, in this GPS latitude, longitude area, or give a high-level meaningful description which machines can read and understand. And if someone was looking for, let's say, temperature data of this room, can find it. Then there are semantics can help us to describe a sensor device. This is the temperature, reports the data in units of Celsius. This is the accuracy. This is the precision of data it provides. And then you have semantics for providing like the high-level processing and analytics for discovery and composition of this service. There are some existing models. For example, we contributed to a work. This is a work by W3C, World Wide Web Consortium, which we created an ontology, take it as a schema to represent sensors, sensor as a device, describing what the sensor can measure, what are the physical attributes of a sensor, what is the measurement range, what is the battery life, and this type of information. This is still as a simplified view. That's what we got after like 2 years working with different people from different disciplines, but all of them, either they were people who were working with sensors or they had interest in using sensor data. The semantic models is easy to make them very complex. The problem is no one will provide. You are making a device. If you have thousands of them, are you going to provide this information? It's easy to create sophisticated models. Once we finished this, we realized, oh, wait a minute. In fact, I was given the task to create some examples for our final report in W3C. And creating one of this took me like a couple of hours. I said, wait a minute, who is going to provide this information? Who is going to provide this metadata for us? That's the biggest challenge. It starts when you're starting, you add metadata, or you say, I add semantics. If you just do a Google search, you will find hundreds, not thousands of papers, scientific research on saying, yeah, we create semantic models. I have a few of them myself, saying, yeah, it's easy to show. You create a model, you add metadata, and it's searchable. It's not. It's really difficult to do this. What we did in W3C, we realized if we do this, it would be no one will provide all this information. Then, after finishing this, we learned from that, and we started making our ontology modular. Then you see we have these boxes, which we said, okay, we have a core. You need to provide a core attribute. Say, this is my device. These are the core attributes of my device. Then the rest are modular. If you're interested, for example, in a deployment-related information, like include this module which explains the deployment, and so on. So forth. Okay, that's for the device. You can go, there are models for the objects, there are models for resources. For the sake of time, I just kept the device model. Now in the service level, there are a number of like service standards, because web community has been working on this. The worldwide web community, they are interested to create software as a service, making everything a service, and then adding metadata against semantics to the services to make them easily searchable, composable, discoverable. The problem is all these standards are dead. No one uses them. Have you come across, I mean, perhaps, I mean, most of you don't work in this area, but I mean, I've tried to search. All of them exist just in the research world. The reason people don't use it, because it's too complex. It's easy to model. You open, there are interesting tools like Stanford, they have created a software called Protege. This is like all the people work in semantics, but including myself, whenever we want to just write a paper, we open, we create a model, we create some instances, and we show it works. But the problem is how you will really, in real world, how you will supply data to this. Then again, the problem with semantic models for the services, especially if you apply them to the sensors, what we have learned through working with them is you have to be really lightweight. Because the assumption is, no, wait a minute, I'll push it to the cloud, sensors won't use this metadata, it doesn't work. Sometimes you need really to store this information on the sensor data. Even the sensor doesn't process them, still you need to keep this data or communicate via like wireless links, via areas which the communication is very costly. Then is compatibility. Again, designing metadata is easy if you assume everyone will follow you. Because you say, okay, I've designed my model, I can interpret it, but if no one uses my model, I'm only interoperable within my own world. Because if you create your own metadata and we use different vocabulary, still my metadata is not processable for you. Then it's very important designing in this model, you start looking at what are the common existing models to do this. The third one, which already I talked about, it is important to make them modular. Based on that experience, we designed a service model, which we call it like, this is a project we work, it's a European funded project called loT.est. But then we have these are the main, for example, modules we have in our service description. And the users, they don't need to specify all the information. You can simply provide only the link to your service. If you have a RESTful service, just put the URI. Obviously, if you don't add the metadata, the discovery of it will be a problem. But if you want to add other information, you can start adding other attributes which exist in the service model. I'll just skip these details, but there are links to our service model in the paper if you are interested. The next challenge is, okay, now we have the services. If I have thousands of the services, millions of the services distributed, how I'm going to discover my service? Service discovery is a problem when you have this semantically described information, and especially this information are scattered, distributed over different middlewares. We used a probabilistic machine learning method to use this. These are like high-dimensional data description. We just use a method which converts them. If you're interested, it's called LDA, latent richlet allocation, which converts our data to a lower dimensional data, and we apply a search mechanism based on that, and then we have, we compared it with other existing methods which are using pure logic or text reasoning, and we showed how it performs. The problem is when you do like dimension change, you lose some data, and when you're searching for services, you need to be exact. Then we learned to use this in combination of a logical reasoning. We use our LDA, our probabilistic machine learning method, to lower to limit the scope of our search when we are searching for the services, and then we use exact logical reasoning to search for the data. I don't have much time. Another problem we face is when you have the model, when you say people will add metadata, the metadata is your vocabulary. When you say this is temperature, you might write it in English, someone might write it in Mandarin. Still you are saying temperature, but you're talking in a different language. Still this information won't be discoverable. What we used a concept is called linked data. It means you have different data sources and you start linking your data to other sources. This is what web community they did. There was a project a few years ago run again supported by W3C. People started looking at the existing vocabularies from different parts of the world, of different vocabularies on different areas. For example, the most famous one is DBpedia. DBpedia just is a conversion of what you see on Wikipedia converted to the semantic information. We thought, oh, that's a good idea. We can use that information to add metadata to our resource description. This is a framework we created. For example, you can add metadata to your sensors to say, for example, where the location is, and instead of adding your vocabulary, for example, here I have written University of Surrey, instead of that, I choose a terminology from DBpedia, which is a linked data, and other people can use the same common vocabulary, then your data becomes more interoperable. In conclusion, this is just a framework. We show how you can make the sensors as a service and integrate them to internet and make them globally accessible and discoverable. And there are already some standardization going on in IETF, for example, to push HTTP protocols into the embedded devices or constraint environments called CoAP, or there is IP for constraint environments called 6LoWPAN. I guess I'll stop here. Thank you. And any questions?